Welcome to The Explainer. Today, we're tearing down a seriously highly anticipated and honestly pretty fiercely debated piece of hardware in the spatial computing space, Snap's brand new, fully standalone 2026 consumer specs. We're going to marvel at the physical engineering, check out their totally redesigned software ecosystem, and, take a hard look at these somewhat turbulent financial realities surrounding this massive leap into true augmented reality.
And we've got to start right here with the elephant in the room. $2,195. Yep, that is the massive price tag Snap has slapped on these glasses. So the immediate question on everyone's mind is naturally, after over $3 billion of internal investment, is true, everyday augmented reality finally worth that kind of ultra-premium price? Are we looking at the actual future of computing here, or just a really expensive enthusiast toy?
Okay, let's dive into this. Here's our roadmap for today. First, we'll explore the true AR middle ground Snap is targeting. Then we'll do a hardware teardown, followed by a look at SnapOS. After that, we'll see how they're empowering creators, and finally, we'll analyze the broader market battleground.
Section 1. The true AR Holy Grail, finding the middle ground. To really understand what Snap is trying to pull off here, we first need to look at the massive dilemma facing the whole spatial computing industry right now. As Evan Spiegel pointed out, the market is currently completely bifurcated. On one extreme, you have headsets like the Apple Vision Pro. They're incredibly capable and totally immersive, sure, but they're also heavy, clunky, and they kind of shut you off from the real world. On the exact opposite end, you've got smart glasses like the Meta Ray-Bans. Now, those are super lightweight, weighing around 50 grams, and highly wearable, but they're basically just a camera and an audio accessory for your phone. They lack true AR displays. So Snap specs are aggressively going for that Goldilocks zone. They want to give us a device that's highly wearable, but also packs a binocular display system that can anchor digital 3D objects right into your physical environment.
Section 2. Hardware under the hood, shrinking the tech. Now, shrinking a wearable computer down to a pair of see-through glasses is just an incredible feat of engineering, and Snap has made some massive leaps since their 2024 developer kit. Just look at these stats. They've managed to bring the weight all the way down to just 132 grams on a 47mm frame. To put that into perspective, their last dev kit weighed a really bulky 226 grams. Yet, even with dropping almost half the weight, they kept a massive 51-degree diagonal field of view using proprietary liquid crystal on silicon displays. Oh, and if you've ever gotten motion sickness in VR, you know exactly why this next number matters. A 7-millisecond motion-to-photon latency. That is literally the lowest publicly stated latency for a 60OF XR product we have ever seen. It basically means digital objects feel physically glued to reality. And all of this is powered by dual Qualcomm Snapdragon processors, giving you roughly 4 hours of active battery life.
And this brilliantly illustrates Snap's attention to real-world usability. Electrochromic lenses. Instead of using traditional photochromic lenses, which, let's be honest, can take a full minute to transition and famously leave you squinting behind car windshields, specs use electrochromic tech. They can automatically shift from completely clear indoors to fully opaque sunglasses in just 10 seconds. That is 6 times faster. It ensures the AR graphics stay vibrantly visible even if you're standing in direct sunlight, and get this, absolutely no phone or external processing pack is required.
Section 3. SnapOS and software, the digital layer.
But as we all know, incredible hardware is absolutely nothing without a polished operating system running the show. Now, SnapOS 2.0 is technically based on Android, but actually, scratch that. It's a completely different beast. You can't just install your standard Android APKs on this device. Instead, Snap relies entirely on its own highly efficient sandbox ecosystem of AR applications that they call lenses, which are built strictly through Lens Studio. This sandbox setup is a total lifesaver. It ensures that one single poorly coded app can't just go rogue, drain your battery, or, literally melt the processors right on your face.
And within this OS, Snap is bringing in some genuinely futuristic software features to solve notoriously difficult spatial computing problems. First up is travel mode. This feature magically stabilizes floating AR objects while you're inside a moving vehicle like a car or a plane, so your digital assets don't just fly away as you accelerate. Then there's Icon. You can say goodbye to those awkward Bluetooth pairing menus. With Icon, you can instantly join a shared multiplayer AR session literally just by making direct eye contact with someone else wearing specs. Honestly, it feels like actual magic.
Section 4. Empowering the creators, code, cloud, and AI.
Now, all of these features are amazing, but Snap knows better than anyone that a platform lives or dies by its third-party developers. So to attract serious creators, they introduced the Native Development Kit, or NDK. Historically, bringing sophisticated C++ code into an AR lens meant starting entirely from scratch. Well, not anymore. Just listen to what Anu Sharma from Mapbox shared at the AWE conference. Her team used the NDK to port their massive location engine, which, by the way, processes 300 million miles of travel every single day, directly onto the specs natively. What used to take weeks of really painful rewriting, they did the whole shebang in just under 2 hours. That is a real game changer.
And for developers building heavy, persistent applications, Snap also rolled out Snap Cloud, powered by Supabase. This is a fully integrated backend as a service that's natively built right into the developer environment. It handles real-time matchmaking, edge functions, and persistent data right out of the box. So basically, Snap is handling all that invisible, complex server plumbing, so developers can just focus on making really fun games.
Snap went even further to lower the barrier to entry by introducing their cloud closed-loop agentic AI framework. Instead of just slapping a generic AI chatbot onto their software, Snap actually mapped out the exact workflows of their top internal teams. Cloud deploys AI agents across 4 exact developer loops. First, in the design phase, it helps prototype UI layouts. Next, it automatically pushes builds to catch bugs in the test phase. Then, it streamlines compliance when you publish. And finally, it silently monitors live lenses to prepare code patches for any crashes during post-production.
Now, what's really interesting about this slide is how Snap is actively courting established XR studios. Think about it. For years, these studios have invested heavily in Unity. Asking them to rebuild their entire catalog from scratch for a new headset, that's a massive financial risk. So the Unity scene conversion skill uses AI as this intelligent translation layer. It literally reads legacy C# code and visual hierarchies from Unity and maps them directly into optimized native Lens Studio structures. It drastically lowers the risk of migrating successful apps over to specs.
Section 5. The market battleground, stock, rivals, and reality.
So the hardware is seriously impressive, and the developer tools are deeply integrated. But how does this all fit into the bigger macroeconomic picture? Well, if we map out the current landscape, it perfectly highlights that bifurcated market Evan Spiegel was talking about. Snap specs are sitting at $2,195, weighing 132 grams with true AR displays. Meta's Ray-Bans are vastly cheaper at around $250 and lighter at 50 grams. But remember, they rely strictly on audio and camera data without any AR overlay. Then you have Meta's Orion. It's an incredibly impressive 98-gram AR prototype, but crucially, it's not a shippable product that you or I can actually buy. Snap is betting that there are consumers out there who want the capability of a true AR device today, even if it carries the weight and price tag of early generation tech. So, the crucial point is that Snap is making this incredibly ambitious hardware push during a remarkably turbulent period for the company. Year to date, Snap stock has seen a severely bearish trend, dropping about 39%. And this launch comes right on the heels of a massive 60% workforce reduction. The financial reality is pretty stark here. As market analysts have pointed out, investor attention is heavily fixated on whether early adopters and enterprise clients will actually open their wallets to validate Snap's incredibly expensive foray into spatial computing. To mitigate that massive financial risk, Snap is being highly strategic about this rollout. Make no mistake, this is not a mass market drop aimed at the average smartphone buyer. Specs are targeting a fall 2026 launch strictly in the US, UK, and France. Production is limited to an enthusiast-focused run of just 100,000 units, and securing a pair requires a $200 refundable deposit. It's a deliberate, calculated move to prime the software ecosystem, getting the hardware into the hands of wealthy early adopters, creators, and developers who are going to build the killer apps we'll need for when cheaper future iterations inevitably hit the mainstream.
And that leaves us with the ultimate question. Snap has essentially shrunk the ambitions of the Apple Vision Pro into a 132-gram pair of glasses. It's an undeniable engineering marvel, fueled by a $3 billion bet. But with a $2,195 price tag and fierce competitors circling the perimeter, we really have to ask, will 2026 be remembered as the definitive turning point when AR finally became a true consumer reality? Or is this just another incredibly expensive stepping stone? I highly encourage you to keep exploring this space, because the next few years of computing are going to be absolutely wild. Thanks for joining me on this explainer, and I'll catch you in the next one.